right. Thank you for coming to our session. Hopefully you guys have had a great TC so far. This is a lunch hour, so if people need to eat, that's totally fine with me, fine with Dimitri. Otherwise, I think the food will still be available after our session. All right, today we're here to talk to you about optimizing Tableau Server for high availability. My name is Kitty Chu, and this is my colleague, Dimitri. First, I'll introduce Dimitri really quickly. Dimitri is from Russia. He actually went to school in St. Petersburg, and that's where he started his career as a software engineer. Dimitri tells me that St. Petersburg is a very beautiful city. I've never been there myself, but judging from this photo, I feel like I would like to visit it one day. So he actually got recruited by Microsoft in 2006, and that's when he moved from Russia to the United States to the great state of Seattle, where we both reside today. After a few years working at Microsoft, he decided to switch jobs and come to Tableau, and he's been with Tableau for the last 7 years. This is his 8th TC, so he's actually never missed a TC since joining Tableau. I think that's pretty awesome. And he was one of the people who designed and wrote a lot of the code in Tableau Server that does high availability. So he's really an expert when it comes to high availability and disaster recovery in Tableau Server.
Cool. Thank you. Let me introduce Kitty. She was born in the state of Maryland and grew up just outside of Washington, D.C. You can probably guess what her favorite football team is. Actually, no. After getting tired for Redskins to get the championship for many years, she decided to cheer for a new team when she moved to the Pacific Northwest as well and graduated from college along the way. Kitty also worked for Microsoft for a number of years before joining Tableau, and she has been with Tableau for the last 2.5 years. As a product manager, working mostly on server administration, high availability, disaster recovery, and related areas. And she worked with a lot of customers, maybe even some of you here in this room, on setting up Tableau Server correctly for high availability, disaster recovery, and she learned a lot of tricks along the way.
All right. So how many people in the room are administrators of Tableau Server? All right, great. It's pretty much all the hands in the room. That's good, because today we are here to talk about Tableau Server. So what is one of your greatest fears as a Tableau Server administrator? Is it getting a 4 a.m. page that your Tableau Server instance is down and nobody can access your server? Well, at least me and Dimitri have been there, and it's no fun. So what we want to share with you today is really how you set up Tableau Server correctly for high availability so you don't have to get pages in the night. You'll know that Tableau Server is still running even if there are certain failures in the system, because we know failures happen. All right, so let's dive in. Today, I'll start by talking about how you actually set up Tableau Server for high availability. Next, we'll actually dive into a couple scenarios of what happens when things go wrong in Tableau Server. And you can see both an example of where Tableau Server will heal itself automatically and fail over, as well as another scenario where we talk about where you as an administrator may need to do some manual intervention. We'll talk through both of those examples. We'll also share some advanced tips and tricks that we've kind of collected along the way working with a number of customers. And finally, I'll touch on disaster recovery a bit, because that's often a topic that's highly associated with high availability, although it is slightly different. We do ask that you save your questions to the end of this talk. We will leave a lot of time for questions, so don't worry. All right, so what is high availability? Put simply, it's making sure that your system is available for as much as possible without incurring downtime to your users. You'll often hear about it referred to as a number of nines. The more number of nines you have, the more highly available your system is. So what are some strategies for achieving high availability? Well, we have two that we use within Tableau Server, and we'll talk about them today. The first is really eliminating single points of failure and having redundancy in your system. So if one process fails, you have another process in the system ready to take its place. The second strategy that we use within Tableau Server, so when you can't avoid having a single point of failure, is being able to reliably detect when there's a failure in the system and then fail over to an alternate or backup system. All right, so now that we have a good understanding of what high availability is, let's take a look at what that means for Tableau Server. Here, I have a standard single node Tableau installation. It's got one of each of the processes installed on it. And by itself, it's not very highly available. You lose the node, you don't have any redundancy in the system. Well, there is one thing I would like to call out, even in a single node installation, is that if you lose any particular process, Tableau Server will automatically restart that process for you, assuming the machine itself is healthy. So there is already some level of high availability built in, even if you just have a single node installation. But we really want to kind of get a little bit more sophisticated than that. So I'll actually talk about two sets of processes. The first is the application processes. So these are the processes that run all your visualization, as well as your extract refreshes. The backgrounder, VisQL server, repository, file store. Those are what we consider the application processes. We also have a set of processes called TSM processes. These are newly introduced as of 2018.2 in Windows, and you would see them if you've deployed Tableau Server on Linux. For now, I'm going to just collapse the TSM process, and I'll get back to that a little bit later in my talk. We're going to start by focusing on the application processes. All right, so here's that same single node cluster with all those application processors installed. The first step I want to do is actually make this a distributed cluster, because a single node is not very highly available. With Tableau Server, we require a minimum of 3 nodes to be considered highly available. So I'll go ahead and add 2 additional nodes to my cluster. You'll notice by default, we have the process cluster controller installed on every node in the cluster. We'll talk a little bit more about the function of that particular process, but just know that as an admin, you don't need to configure that. That gets automatically configured for you and installed on every node. So I'll start by looking at Data Engine File Store. What does Data Engine and File Store do for you? It stores the extract files for any extract-based workbooks in your cluster. So if you lose that Data Engine File Store pair, you won't be able to access, none of your users will be able to access their workbooks that rely on extracts. Well, the first principle that I talked about for achieving high availability was creating redundancy in the system. So the simplest thing to do is to replicate Data Engine and File Store pairs across all the nodes in the cluster. So here I've added them to node 2 and node 3. With File Store, one of the things that you may not know is that File Store automatically will sync the content between all the nodes in the cluster. As a user, they just publish to a single instance of File Store, and in the background, Tableau Server will take care of replicating those files across to all the instances of File Store. In cases of large extract files, sometimes that syncing does take time, and so there is already functionality built into all the application processes that access File Store to know to search across all instances if it can't find a particular extract file in one of the file stores. So with that functionality, again, as an admin, all you need to do is to provision those multiple instances of File Store, and Tableau Server will take care of the high availability in the background for you. All right, so that takes care of Data Engine and File Store. Now I wanted to talk about the repository. So unlike data engine and file store, repository is sort of a single point of failure for Tableau Server. You can only ever have one instance that all the processes use to access. And what does the repository store? So it stores your user information, it stores the permissions of the workbooks, all the projects, sites. All of that metadata information is stored in the repository. So it's a really critical component to the functioning of Tableau Server. So what do we do since we can really only have one active instance? Well, the repository is actually built on Postgres, which is a database. And if you're familiar with Postgres, you can set up Postgres to have a passive repository. And so that's actually exactly what we'll do. We'll set up 2 instances of Postgres in our cluster. One will be designated the active, and that's what all the processes will use to communicate when things are running normally. And we have that passive that's configured. And Postgres has the functionality to do streaming replication between the active repository to the passive repository. So then if anything were to happen, that's when we would need to fail over to that passive repository. All right, so now we have repository and data engine and file store that are highly available. Now let's look at the rest of those processes. So repository and file store are really what store a lot of the persistent data all the data that we really need to keep within the system. These other processes, some of them still have some state, but a lot of that state can be rebuilt. And so we consider them somewhat stateless processes. And for those, it's really straightforward to set up high availability. It's really just, again, eliminating those single points of failure and duplicating those processes across all the nodes. So I've gone ahead and added this set of processes across all the nodes in the cluster. And now, if I lose any particular node in the cluster, I know that I still have another instance of that process running somewhere else. I can actually go a step further on this. So for the light blue processes that I've highlighted there, you can actually configure multiple instances of those processes even within a node. And that gives you even more high availability. So you lose a single process on a node, you still have some redundancy even within the node. So this is starting to look like a pretty highly available installation of Tableau Server. Now let's look at how customers connect in to Tableau Server. So for a customer connecting in, you have to give them some machine name or some IP address to connect to. Well, in many cases, it would be just one of the machine names of one of the nodes that has a gateway installed on it. But now, if you lose that particular instance of gateway, you're not highly available anymore because your users can't actually access the rest of your server, even though you've set it up for high availability. So a really common strategy is to simply put an external load balancer in front of the entire cluster. Your users actually hit the external load balancer, and the external load balancer can load balance the traffic evenly across the different nodes in your cluster. And because we have gateway configured on each of the nodes, each of those nodes can take end user traffic. All right, so now we're pretty much done with getting our Tableau Server 3-node highly available installation set up for those application processes. As I mentioned earlier, we also have a new set of processes called the TSM processes. So let's look at what it means to set up HA for TSM processes. For those of you who don't know what TSM stands for, it stands for Tableau Services Manager, and is a set of new services that we introduced to help manage the Tableau Server instance itself. So one of the first things I wanted to introduce was the concept of Zookeeper. So Zookeeper, or the coordination service that you might know in Tableau Server, is what keeps a consistent view of the state in your service. We actually had the notion of a coordination service ensemble, even in legacy versions of Tableau Server. So it's not a new component, but with TSM, it's taken a larger role. And so now we've included it as part of the TSM processes, and it stores it stores even more state of the system. One of the key concepts that's really critical to the functioning of coordination service is this notion of a quorum. And what a quorum is simply having a majority of the nodes agree on the state of the system. So if I only have 2 nodes and they don't agree on the state, I don't know who to trust. There's no one to tie break that situation. So that's why we require a 3rd node in the cluster to be considered highly available. With 3 nodes, I can have 2, as long as 2 of the nodes agree on the state of the system, I still know what the state is, and I can still be highly available. So, just to reiterate, 1 and 2 node installations of Tableau Server are not considered HA. You need at least 3 nodes in order to be considered HA. For an even more highly available configuration, if you have 5 or more nodes, you can actually go up to a 5-node coordination service ensemble. And when you have 5 nodes, you can lose up to 2 of those nodes and still have that majority quorum established. All right. So now that we've gone over what the coordination service does, let's look at how to apply this in terms of HA for our TSM processes. So here's that same 3-node cluster that I was showing you before. But now I've collapsed down the application processes, and we're going to focus on the TSM processes. So there's 6 TSM processes that are shown on the first node. You'll notice that Agent and Service Manager are already installed on node 2 and node 3. Much like the cluster controller, those services are automatically installed for you whenever you add a new node to the cluster. That's not something you need to manage or worry about. So we'll focus on the other ones kind of above Agent and Service Manager. The first is the coordination service, which I was just talking about. So right now, we just have coordination service deployed on our first node, so it's not very highly available. The first thing that we would need to do is deploy a coordination service ensemble. Since I have 3 nodes, I'm going to go ahead and deploy coordination service across each of those 3 nodes. This is a manual step that you as an administrator need to do in order to set up high availability. The other service that I wanted to talk about is the client file service. So this is similar to the file store over on the application process side, but it's used for storing files that are needed for configuring and managing Tableau Server. So these are things like your SSL cert files, maybe any custom logos that you have, things that are needed to run server. So again, we want to make sure that we have high availability here. So we'll go ahead and put an extra instance of client file service on node 2. Now I have some redundancy in the system. You'll notice that I still have 2 additional processes TSM processes that I haven't really touched on, and that's the controller and licensing. With controller and licensing, we'll talk about a little bit later, but in terms of configuring your cluster, you can only have a single instance of those running across your cluster. And so that's why we have those running on node 1. So really, this is considered a TSM. This is considered a highly available configuration of TSM in a 3-node cluster. All right. So now that we've set up our cluster for high availability, I wanted to turn it over to Dimitri, and he'll go over what happens when things go wrong.
Thank you. Availability is and how to configure it in Tableau Server. Now let's see what happens when things go wrong. We'll start with repository failover. And before we talk about repository failover, let's talk about cluster controller. that process which you saw was installed on every single node already. So what does it do? So as I already said, there is a single instance of it on every node, and one of these instances will be elected a leader for this particular cluster. And what it does, it monitors state of the Postgres or repository processes running on those nodes where they are configured to run. And if something happens to a repository, like failover happens, it updates configuration for all other processes to know where the new active repository is. It also monitors health and status of other processes, and if something goes wrong, it sends notifications if those processes are unhealthy. Okay, now let's see how repository failover actually works. We have this 3-node cluster in this example, with active repository on node 1, passive repository on node 2, and we have Zookeeper ensemble across these 3 nodes. And streaming replication is going between active and passive repository. Cluster controllers monitor the state of these repositories, and we have a leader cluster controller, in this case on node 1. Now let's see what happens if node 1 goes down. First of all, since we still have 2 more nodes in our Zookeeper ensemble, they can establish a quorum and they can agree on what the state of this cluster is or should be. And very first thing they will do is they will elect a new cluster controller leader. Let's say in this example it is cluster controller on node 3. The leader cluster controller, after noticing that Postgres or repository, active repository is not there, it will trigger failover. And the passive repository on node 2 will be the new active repository. And cluster controllers on all other nodes will update the configuration of other processes to point to this new active repository. And the cluster can work just fine. If node 1 recovers, if by itself or you rebooted it and it joins the cluster again, repository on node 1 now will be passive repository. And the changes in active repository will be streamed other way around, from node 2 to node 1. Now let's talk about recovering from initial node failure. This diagram Kitty was showing us just a few minutes ago, as you probably noticed, we have still 2 more processes which are single points of failure, which are on node 1. It's controller and licensing. Now let's see what happens if something happens to our node 1 and we are losing these 2 processes. First of all, don't panic. Because if you configure Tableau Server for high availability, it will continue to run. If you have multiple instances of other processes, they are still serving traffic. If repository had to fail over, it did fail over, and your server is up and running. What you are losing at this point is the ability to control your cluster. So you cannot do any changes to your cluster. You cannot even stop it at this point. So how do we get out of this situation? The easiest way would be to repair node 1, and another process which you are missing at this point is licensing process, and it might be a problem that your processes may get unlicensed, but we have a grace period of up to 72 hours, so you do have time to repair your node 1 and get back to the good state. But it is not always possible. So now let's see what we do if you cannot repair node 1. First of all, you need to move controllers somewhere else, because this is what allows you to actually make any changes to the cluster. There is a script installed on every node where you install Tableau Server, which allows you to move controller to a different node. It is this move TSM controller script. You should just execute it, and you have controller on a different node at this point. Now you can go get control of your cluster back, and you can stop it, Tableau Server, for example. And this is what you need to do next. Just go ahead and stop Tableau Server and move licensing service from node 1, where it was originally, to some other node, node 2 in this example. And after that, you can activate licensing keys on node 2. You want to remove node 1 from your topology and all the processes which were configured on node 1, if this node is not coming back. And you may want to get back to highly available configuration, you may want to add a different node to your system. So in this example, it is node 4. And you want to configure the same processes which were originally on node 1 to run on node 4. So you have effectively the same Tableau Server configuration as before the failure. And now you can start Tableau Server, and it will work just fine. There is a link to the documentation at the bottom of this slide, which talks in more details how it all works and what you need to do. But this is roughly what it is. Now let's talk about some advanced tips and tricks you can do with Tableau Server. First, deploying external coordination service cluster. So what it is and why is it interesting? So coordination service is a very important process in Tableau Server, and especially when you run on low-spec machines, it may compete for resources with other processes, and sometimes it is a good idea to move it to its own set of nodes. And you need at least 3 additional nodes to actually do that. So how do you do that? So you install Tableau Server cluster as usual, and then you stop server, and you add 3 more additional nodes, which will be your coordination service nodes. And the next thing you need to do is to move coordination service to these additional nodes. There is a set of TSM commands you need to do, which moves coordination service from the nodes it was originally configured to run on to its own coordination service nodes. So if you do the status command, after that, you can get something like this, that your coordination service on these 3 nodes, nothing else is running on them, and the rest of your Tableau Server on the nodes it was originally configured to run on. Tip number 2, optimizing Tableau Server for specific workload and high availability at the same time. So in this example, we have a pretty large Tableau Server cluster, but the nodes are playing slightly different roles in this configuration. For example, node 1 and node 2 are our interactive workload nodes. This is where users come with their requests. This is where viz rendering happens. This is where browsing of Tableau Server happens. 2 other nodes are backgrounder nodes. These are the nodes which perform all the extract refreshes or subscription notifications. Basically, all background tasks are performed on these nodes. We have 2 more nodes which are our repository nodes. This is where we have Postgres configured for high availability, or repository configured for high availability, with both active and passive repository on different nodes. And we have our coordination service nodes from previous example on their own 3 workers. And we can actually take it even further. For example, we have data engine on nodes 1 and 2, and data engine and file store pairs. If your specific setup is very extract heavy, and you have a lot of extract rendering and a lot of extract refreshes, you may also separate them on their own machines so they don't interfere with other Tableau Server processes like vSQL Server or vSportal, for example. Or you can also move search and browse process or pretty much any other process to their own nodes. Tip number 3, deploying to public clouds. So before we talk about deploying to public clouds, let's talk about some terminology which is commonly used there. So there are concepts of regions, and regions are separate data centers geographically distributed across the country or even across the world. Pretty much all cloud providers use this concept. And within the regions, they also have the concept of availability zones. And availability zones are independent parts of the region, which have like independent power, independent cooling, pretty much independent everything. And cloud providers guarantee availability by availability zones, not by individual machines. So if you want your deployment to be highly available, you want to deploy to different availability zones and not necessarily different machines in this case. So what does it mean for Tableau Server? So you want to deploy Tableau Server to multiple availability zones, and you want to deploy to the regions which have at least 3 availability zones. It is a similar concept to deploying to at least 3 machines, but since cloud providers guarantee availability by availability zones, you want these 3 machines to be in different availability zones. Since availability zones have low latency network between them, the Tableau Server will work just fine, even though we generally don't recommend deploying to multiple subnets, and this is effectively this. Cloud providers guarantee that it will work fine. And with that, I'm turning it back over to Kitty, and she will talk to us about disaster recovery.
All right. Thanks, Dimitri, for sharing all those great tips and tricks. Hopefully, you'll find some of those useful. All right. So we've been talking a lot about high availability, and that helps to deal with failures and issues that might occur within a cluster. But there are those situations when high availability just isn't enough. You have a hurricane or earthquake that takes out an entire area or region. And so now that's where you need something like disaster recovery. There are 2 concepts that I wanted to introduce or talk about with respect to disaster recovery. The first is RPO, and the second is RTO. RPO stands for the Recovery Point Objective. So from when the incident or disaster happens, your RPO is the amount of data loss that you're willing to sustain. So that is often determined by when you took your last backup and how often you take your backup. The second concept is the Recovery Time Objective, or RTO. And that's from when an incident happens, how long does it take you to get up and running again with the data snapshotted to the point where you took your last backup. And so generally, when you talk about disaster recovery goals, it's a combination of both the recovery point objective and the recovery time objective. You want to, if you're trying to optimize for disaster recovery, that's where you want to minimize both of these metrics. So I'll talk about strategies for doing both. The first will be RPO. So with RPO, really what it is about is taking regular backups. How often you take your backups will determine the RPO for your organization. It could be once a week, it could be daily, or even every few hours. So what are some gotchas or tips and tricks that we can share with you around backups? Well, the first one is backups do take up a lot of space. And so on the node that you're taking your backup, we do recommend that you have extra storage space on that node, because sometimes just compiling the backup itself can take 2x amount of space. The next thing that I would want to call out about backups, although it may be obvious, is that you want to move your backup files from the local server to another location, and ideally in another region, or store it in the cloud somewhere. Because if you store your backups on the same machine where you have your disaster, you're not going to be able to access those backup files. So it's really important to not only take backups regularly, but move them to a different location. And then finally, make sure to secure your backup files. There is a lot of sensitive information in those backup files, and so we do recommend that if you are storing them somewhere, make sure that you know who has access to them, and if it needs to be encrypted, you can also encrypt those backup files. All right, so that will get us good RPO. How do we address reducing RTO? Well, there's really a spectrum of what you can achieve here, and a lot of it will depend on what's appropriate for your organization. For the highest RTO, you may not have any dedicated machines for disaster recovery, and you would need to acquire and procure those machines from scratch, install a brand new installation of Tableau Server, and then restore the backup, the last backup that you have. Depending on how long all of that takes, it could be days or hours before you get up and running again. Something kind of intermediate is if you had a cold standby cluster. So you have some machines ready, but you're not necessarily investing the resources to regularly restore those backup files, and you may need to update the version of Tableau Server you have on there. That may be on the order of a few hours before you get up and running. For the lowest RTO, really the best practice is to have a dedicated DR cluster. So let's take a look at what that would look like. Here I have an example of a primary cluster on top here and a DR cluster on the bottom. Notice I call out that they're in two different regions, and that's important. And they have the same number of nodes, and they have the same configuration. Both are running, and what I've done is put an external load balancer in front of those two clusters. Again, my users are going to hit that external load balancer, and depending on where I've set up to redirect traffic, it'll either hit the primary cluster or the DR cluster. So when things are running normally, everything's going to just go to the primary cluster. My backup cluster is just running kind of on standby. The other thing that I need to do regularly is restore any backups that I'm taking from my primary cluster to that DR cluster, so that DR cluster is always up to date, at least to the point of my last backup. Then if anything ever happens and I need to switch to that DR cluster, it's already up to date and ready to go with some of the latest information. So if I do, like I said, if there is a disaster, all I would do is reconfigure the external load balancer, and within a few minutes, my users will be hitting that secondary cluster and accessing the data that I've already restored there. The only thing that they might notice is any recent extracts that have been published may not show up, or if some data was just refreshed, again, that would not be up to date, but it would come up to date the next time that extract refresh was scheduled. So that really is what we kind of consider the best practice in terms of disaster recovery. With that, I'm going to just throw in a pop quiz, make sure folks were paying attention to us during this talk. My first question is, can anyone tell me what is the minimum number of nodes in a cluster to still be considered highly available? All right, I see a lot of threes. All right, good, great. Everyone was paying attention to that piece. The second one is, can you guys name the two TSM processes that do not support automatic failover and redundancy today? That's right, I heard it. I heard both of them. So it's the licensing process and controller. But as we mentioned, they don't really impact the general functioning of Tableau Server, so you do have time if you lose those processes to get things back into a healthy state. And then the last question, where should you store your backups? Somewhere else, that's right. All right, as long as it's not on the Tableau server where you took where you're backing up from. All right, awesome. Well, thank you so much for coming to our talk. We hope that through learning, through attending your session, you guys can now sleep peacefully through the night like a baby, because you know that Tableau Server will be set up correctly for high availability. There are a couple, we're almost the last session of the conference, but there are a couple more sessions that I just wanted to highlight that are happening just right after this. One is on Tableau Server security in depth, if you're interested in that, as well as a great talk by one of our colleagues to talk about what's coming up new in Linux. So if you guys have a chance and haven't figured out where you want to go next, those are some great sessions to check out. We also wanted to encourage everyone to fill out the survey in your TC18 app and give us feedback so we can improve every year. And thank you so much for coming. We're now happy to take any questions that you guys might have. There, yeah.
Question. So our company using core-based license. So if we want to go to cluster distribution, what kind of like support for each node to have that command for, or it's
That's a great question. So the question was, with core-based license, you know, what sort of core-based license model works with high availability? So we do recommend the minimum number of cores that you would need in order to achieve high availability is 16 cores. And so that would allow you to still get to 3 nodes. You would have all your processes kind of where you want that redundancy in your system across 2 of the nodes. And then you'd have a 3rd node that really just hosts any unlicensed process. It could be the node that has the licensing process as well as the coordination, host that 3rd coordination service ensemble that's required.
2 6-core on the 2 main one and 4 that on the 3rd.
It would be 2 8 cores.
That's 16.
That
Yep.
would be 16. And then that 3rd node, because you have only unlicensed processes on it, it wouldn't consume any licenses.
Yeah, processes like a repository, gateway, search and browse, and all of this, they don't require licenses, so you can have a node which doesn't have any of this Viscal server or data engine processes which are licensed. That will be totally fine.
Yeah, if I go back to.
The first 2 8-core one, it's the one have the passive and the active repository.
You could do that, but it is not necessary. So let us get back to this picture. So the light blue processes and the green processes are those which require licenses. So if your 3rd node doesn't have any of those, you are still highly available. So your repositories can be on nodes 1 and 2 or 2 and 3, for example. We don't license a repository. For example, your repository can be on its own machine. It will be very happy to not conflict with anybody else.
We really need that 3rd node to establish the quorum,
Yeah.
as I mentioned.
Yeah,
So-
really, the 3rd node is a tiebreaker if something goes wrong, but you can take advantage of it. So you can put your gateway there, you can put your repository, you can put search and browse. They still play a very important role in the overall functionality, but they will not be competing for resources with light blue and green processes.
Yeah. And we're really talking about the minimum configuration for HA. Obviously, if you can invest more, then you can fully utilize all 3 nodes. But if you, in terms of like the minimum that we can recommend for customers, it's really 16 cores.
In his situation, would it make sense to license 6 and 4 for 16?
No, so in terms of what we recommend for Tableau Server, for anything that's actually running any sort of workload, we require 8, or we recommend 8 cores, a
So it
minimum
will
of
be,
8 cores.
will be much better if you do 8 and nothing in terms of licensing.
Do you have this document somewhere of what process require the license?
Yeah, that is documented on in our online help documentation. If you just search for Tableau Server processes, there's a table that shows you which processes are licensed and which ones are not licensed. Yes?
How do you recommend software upgrade to handle these?
That's a great question. So, you know, that really varies on the needs of your organization. If you're okay taking some downtime and taking some planned downtime, then you can just upgrade all the nodes at once. But if you want kind of to keep that system highly available, you do have the ability to take down each of the nodes individually, upgrade them, and then bring them back up, and then just restart it.
You mean that two old version connect
No, so this is, I'm assuming the question was around OS patching, not, were you talking? Tableau upgrade. Oh, all right. Sorry, my apologies. So for doing a Tableau Server upgrade, with TSM, what we allow is that you can actually install the newer version of Tableau Server alongside your existing version of Tableau Server. And then once you've kind of laid down the bits everywhere, you would need to take some amount of downtime to perform the upgrade. But with our new upgrade process, we've seen probably no more than like 15 or 20 minutes to actually run the upgrade script across all the nodes, because everything's already kind of in place at that point. And the only downtime you need to take is to run that upgrade script.
So just to add on that question, so we're actually currently a single node, right? So we don't have this capability. And we don't like to do an in-place upgrade. What we do is, for other reasons, like for example, we're upgrading a Windows OS, right? So we're installing a parallel environment where we're going to install the new version of Tableau. How does the licensing work? Because if I want to activate license there, I'm technically not licensed for 16.
Yeah, that's a great question, and I actually forgot to mention it even when I was talking about the DR cluster. So within the Tableau Server license agreement, you are allowed to have up to 2 additional clusters or instances of Tableau Server running for things like disaster recovery or like doing this in-place upgrade, or sorry, not the in-place upgrade, but this kind of temporary upgrade process. The only thing that I'm just going to call out is that after you switch over to this new cluster, make sure you deactivate the license. But that type of situation is completely covered, yeah.
So kind of a follow on to that, is in the situation where you lose your licensing server, your initial node, that licensing server is gone, you can't deactivate the license. Do you lose that activation? What happens there?
Yeah, you do lose that activation. We do have some kind of grace activations built into the key for scenarios like that. But if you ever do run out of license activations, that's something you can work. You can contact support in your sales representatives, and they can usually fix that.
And how's it going to work when you move to the subscription model from core? I think we're all discussing core.
Yeah. Really, subscription licensing doesn't change much about our talk, except for now you're not limited to, I need to figure out how to distribute the number of cores that I have. So you can actually scale out to as many nodes as you want.
So it actually makes it very easy for you, much easier than, so you can do what I had on that slide, optimized for various workload clusters.
Like up to 9, 10 nodes, yeah, as many as you need. I want to make sure I get some questions in the back there. Maybe this gentleman over here.
I just wanted to check, you made comments of how long this would take. Is that the same for both Windows and Linux?
Yeah, it's roughly on the order of 15, 20 minutes to do the upgrade, yeah. And it will depend on your machine specs and the number of nodes that you have in your cluster, so there is some variance there.
But in the case of an upgrade, you also would be doing any backup restore.
Yes, there's no backup restore happening, yeah. Yeah. Yes.
If we go to the multi-node cluster, we get better alerting. Like we're on a single node right now, we only get up events. We get events for other nodes like down and up, and then like react to those triggers. And even when you're talking about the script to run to move the services, like across the cluster controller, can we get something that we can tie into to script that so we don't have to manually do that?
Yeah, actually, the reason you're getting only up events, because the node which would send you down events is the node which is down. So if you have more than one node, you will be getting both down and up events at this point. And cluster controller will be the process actually sending you this information.
And then is there something, is there like, I don't know if it's REST API or something, it seems like that's a tab command script to move the cluster. So say we know it's down, we don't want to wait to move the cluster. Can we automate that process as well, or is it just kind of a custom workaround to do that, as opposed to just going into the node and then running the script to move it?
I mean, you can, they're all scripts or CLI commands, and so you could, in theory, write your own script, kind of like Yeah, and make that an automated process. That's not something we provide out of the box, but certainly something that you could do as an admin.
Yeah, it actually does a bunch of these CLI calls and REST calls under the covers, so you can mimic that and have it doing the same thing. Yep.
My question is, currently I have a 3-node high availability, and I like the idea of moving the repos to maybe 3 and 4. So would you still recommend the RAM to be like 32 gigs for the repositories if those 2 servers are running that?
The more is better. So maybe if you are running them on 32 gigabyte machines right now with the rest of other processes, maybe your repositories don't actually need 32, and maybe they will be fine with 16, for example. But if you give them 32, they will happily use it, and you will get faster, effectively, database. Database is always hungry for memory. They just cache more stuff in memory at this point. So you will get slightly better performance. It may be not worth it, or it may be worth it. Yeah, depends. As usual in these cases, it really depends on your scenario.
So just to be clear, the high availability configuration does not assist in any load balancing, right? It's nothing.
No, it's actually not true. It does help you, especially if you scale out your data engines, and if you scale out light blue processes and dark blue processes, they all will start serving your traffic. Repository is the only one which doesn't scale because you always have a single active repository. Everything else pretty much scales at this point. So if you are extract heavy, it actually will be very beneficial for you to scale the green processes. Yep.
Did you have a?
Performance implications have you seen when you're using high availability spread out horizontally? And with the, for instance, the cache is going to be across more machines. The cluster controller is going to go back and forth trying to figure out where to pick the cache from, blah, blah, blah. You're going to have more chatter amongst those servers.
Yes.
What performance implications have you seen, and how do you account for that?
So yeah, you're absolutely correct. There will be more chatter going on in this case if you have machines spread out and processes spread out of these machines. Cluster controller doesn't actually play any negative role in it. Data engines will be syncing large extracts between them, so they will utilize some network at this point. And some of your processes, so for example, this portal on node 1 connecting to repository on node 1 obviously will be slightly faster than this portal on node 3 connecting to repository on node 1, but it's usually not noticeable. So if you have good enough network, you will get much better performance.
So have you done testing to
Yeah.
see what the
Yeah.
difference is?
Yeah, we have a white paper. We had it for a few years on how to scale.
When you spread them out, though, because I've read your white papers and they don't account for the high availability options that you're talking about.
It's, I believe, a different white paper for scale out, right?
The scalability white
That
paper?
addresses the performance.
Yeah, yeah.
It does talk about scale up versus scale out, I believe.
Well, it does, but you're scaling out here in high availability, and it should have some. So it's not gonna be exponential. It's gonna be the performance is gonna not. Every time I add a machine, it's not gonna be linear performance, right?
That's what's covered in the.
Those papers don't cover what you're talking about here, because in one case you added 5 new servers, right? It doesn't talk about that. It talks about these kind of configurations and when you use the same configuration. It doesn't talk about spreading out components like you're talking about.
Oh, you're saying like in our other one where we had repository on their own nodes and like dedicated backgrounders. Yeah, I mean, I will say anecdotally, working with a number of customers, a lot of them have seen performance gains by moving to these kind of like more dedicated workflows. And like Dimitri said, there is gonna be there will be some increased network latency, but I think the performance gains you get from actually spreading out across more nodes kind of outweighs that.
Yeah. And also there will be an additional benefit. So if you have your interactive workload nodes and your background workflow nodes, if you are bottlenecked in one of them, you can only scale that part and leave the other one as is.
Yeah.
We actually internally run Tableau servers
It
like
just seems,
that.
yeah, I think we're
inside
like
Tableau.
more compute and memory bound in general
Yeah.
than, bound by network traffic.
And a comment about some of the things you were saying in your presentation. For the restore command, it requires at least 3.5 times the size of the backup in order to restore.
Yeah,
So when you were saying twice, that may be kind of misleading to if people are expecting to do a restore on that same machine. They probably want 4 times whatever the size of the backup is. Just to be
yeah,
safe.
that's a good point.
And then on one more point.
Sure.
On your RTO, that's when you showed that was the lowest RTO, that's actually the best case, because if I'm in the middle of a restore and the server goes down, then I can't use the backup
That's
until it finishes the
sure.
restore.
Sure.
How the backup job's gonna do on the 3-month cluster?
What do you,
I mean, is that gonna have 3 backup files created?
No.
Oh, no, the backups are always taken on the node that's running controller. And so it will make sure, the first thing it does is actually it'll make sure that all the files are synced to one instance of the file store. And if you have file store configured on the same node as that controller, that's the one that it will pick. So for speeding up backups, we do highly recommend that you put a file store on your initial node.
If it's not completely synced and then run the backup.
It will sync,
It will sync
before it
automatically.
takes the backup. Yeah, so we will make sure it's in a consistent state, then we take the backup. And it's only taken on that one node.
Only on that node.
Yeah.
Correct.
And if you do it while the server is running, same is actually happening. So this node is, okay, I have to have all the files at the moment you gave me backup command, and it will make sure that all
Thank
the files
you.
are there, but everything else continues to happen at the same time.
All right, we're happy to take more questions up here, but
Yeah,
I
please
know
come.
other people want to get to other sessions, so we want to respect your time.